In this video, I'm going to talk about this Go board I made for my Design and Technology IGCSE project. Go is a game that's played on a board that's made of squares. It's 19 by 19, and each one of the two players takes turns putting down pieces on the square. And the aim of the game is to surround the other player's pieces and take as many of the squares as you can. It's very often played in China and Korea and Japan, and this is my very unconventional version of a Go board. This is what a Go board normally would look like. It's just a basically square piece of wooden board that has these grids on one side. Often on the other side, there are markings for Chinese chess, which is a completely different game. But for now, we're just focusing on the Go board. There are black pieces and there are white pieces. The pieces look like this. They're almost completely flat and circular. And players play on the crosses rather than the spaces inside the squares like chess. So obviously the whole shape and form of this Go board is already very different from most Go boards. There's a very obvious Ying Yang pattern on the top made of two different types of wood. And you might be wondering why the top surface is made of a grid of spherical holes rather than lines. And that's because the pieces in this Go board are stored in these Ying Yang shaped compartments, and they are solid metal spheres instead of flat playing pieces. This side is brass, and it's the equivalent of the black pieces. On the other side, which opens out the other way, there are stainless steel balls that act as the white pieces. And so instead of placing flat pieces on a flat board, on this board, you place the spherical pieces in the spherical holes. There are a bunch of different small details on this Go board. For example, I designed the dimensions of this rectangular slot just right, so that the spheres would pack in the hexagonal optimal pattern. There's this 3D printed handle that attaches onto the two storage compartments, and they're screwed in by two screws from the side. And below the main playing surface, it's almost completely hollow. What you don't see is that the rod that attaches the two playing compartments are actually also made of steel and brass. So even though those two are hidden, it's another way in which there's this yin-yang pattern, the mix of two materials, the mix of two colors, the mix of the two different types of wood. And this whole board just seems to be about the mix of two different types of materials. On this side, there's a black acrylic piece that's lining the inside of the rectangular slot. And on this other side, it's a white acrylic piece. Again, two different materials. Getting to this point took a very long time. For the Design and Technology IGCSE, it's not just that you have to make a final product. Just as important is that you have to make a whole folder detailing your whole journey through the design and manufacturing process. And here's my folder, which in total took about 1.5 years to make. And now I want to show you through this whole folder. It's very, very long. I think I counted it something like 100 A3 pages. And that's because for this folder you have to be very, very detailed about every step of your design and manufacture process. For example, the very first thing we do is identify a problem and come up with a brief for the whole design process and roughly what the final product would look like. The idea is it's not just a project that you're making yourself, you're supposed to have a client that you're making this project for. And my client for this project was a friend at school who also played the game of Go. I have a page introducing the rules of Go, and then here's the analysis, where the whole point is you ask a bunch of questions about all sorts of problems that could come up in the design and manufacturing process. Things like, how much would the wood cost? What should I consider in the ergonomics? How big should it be to fit different users? What kind of wood joints should I use in the product? These are all questions that I'm asking at the very start, so that next I can do the research and specification with a lot of questions in mind. With the research I made a plan, and then I made a mood board, and I started thinking about all sorts of things. I did a page of research on wood, different types of wood joints. From the start, I already had the idea of using spherical balls in mind, so I did a small test on the school's CNC machine and milled a few spherical holes on a piece of wood and tested how well the metal balls would fit. I searched up suppliers for these metal balls, and then I did some materials research with different types of wood to see which ones would work well. I had an interview with my client, my friend. We talked a bit, we talked about what specifications he has, and then we visited our maths classroom, since our maths teacher is actually also a Go player and has all sorts of different types of game boards, chess boards as well. I then looked at all sorts of existing products online There are many different types of Go boards. There are the simple ones, like the one I showed earlier, but the most professional ones are actually a full block of wood. This is a completely solid block of wood, and the grids are marked on top of it, so you can imagine how expensive this would be. But most are just the simple flat type with 2 balls of pieces. I then came up with a list of specifications for what the final product must satisfy. For example, I said all the joints must be hidden. It must have a 19-piece by 19-piece layout. I set limits on the cost of the materials, and I set limits on the maximum size of the final product. And then now, with all of these specifications in mind, there's a whole process that we went through for generating different ideas. First, we just did rough sketches of all sorts of crazy ideas. There's no limit on how crazy you can be. You see, I even thought about having a board and chairs suspend from the ceiling that act as lights once they retract. I thought about a dodecahedron shape Go board, all sorts of different crazy ideas, just to start off with. And then we chose 4 out of these roughly 16 ideas and extended them further in greater detail. Here's the first one. It's kind of traditional with a drawer and just the grid at the top. We dimensioned them in detail and did some design drawings. And I also 3D printed a very small model to see what it would look like in my hand. Here's the next one, and it's actually the very initial idea of what evolved to become this final form. I initially thought to have different circles stacked on top of each other like this, but I could already tell that would be very unstable. And later on I do address that and develop the idea into what it is finally. I did all sorts of calculations and made a small CNC model just to test out the rough form. My third idea was just a completely flat board. Below is the storage compartment, and a completely separate board would go on top of that to act as the playing board. And I also had pencil drawings down here. And the last one is the most different. This is my electronics knowledge leaking through. This idea was that the top would be a circuit board, and instead of having physical pieces, it would be an array of LEDs. And each grid would have 2 buttons, and depending on which player is taking that grid, it would either light up as red or green. I thought about what circuits could make this possible, and I even made a physical prototype of different ways of achieving this mechanism. And here's a circuit of different ways of making an SR latch. Now I took the 4 greater detail ideas and compared them back to the specification from earlier. And I thought about how each one fits or doesn't fit the specification and marked the places where it doesn't fit in red text. And as you can imagine, since the 4th electronics one is so different from what I initially had in mind, it fails a lot of the specification points, and it's not something that I pursued in the end. And so I decided to go with the first 2 greater detail ideas. And next is the process called development, where you take the idea and make a small change to it, and draw it, and then make a small change to it, and then draw it again, and making all sorts of comments during the process. So you can see how I removed the unnecessary middle section and made it semicircles to simplify. And then I removed even more waste, and I decided to change from semicircles to the Ying Yang shape, since Go is an Asian game and the Ying Yang shape is also very much related to that. I had all sorts of ideas on how all the pieces were going to fit together and how I was going to use the rods to hold everything together. And you can see I initially had the idea of having the 2 compartments pivot through the center of the circle, and that would be pivoting through the center here. But in the final product, what I actually have is the 2 compartments pivoting out from the tail, roughly here. And you can see later here in the development process, I made that change. Here's also one very important part. This is what the internals of the 2 storage compartments actually look like. There's a flat piece of plywood at the top, a flat piece of plywood at the bottom, and then vertical rods holding these together. So the outer skin of the storage compartment is actually a very thin veneer. You can kind of hear it's quite hollow. I also did the calculations for how the balls would fit together in the storage compartment. I designed the 3D printed handle here. And then I described some of the physical models I made during the development process. That was the first design. I also repeated the whole development process for the second design with the drawer, making small changes bit by bit, designing a 3D printed handle, and also describing some of the modeling used in this process. This idea wasn't the one that I ended up pursuing, and so you can probably see by now why there's so much work going into this whole DT project. Throughout the whole process, there are a bunch of designs that you think about and describe in detail, but there's only one final product. So a large amount of the time is spent refining and narrowing down to this final product so that it can be as good as possible. Just like before, I compare the two final results of development to the original specification. And I say here how I'll settle on the first one to make at the end. So now there's the plan for how to actually make the final product. I designed the final thing in Fusion 360 and made all sorts of views and diagrams of what it would look like. I described the whole manufacturing process, also using 3D models, and I included detailed diagrams of all the dimensions of all the shapes involved. I list the tools that I would use during the manufacturing process, and here is a very long list of every single individual action that I do during the act of manufacturing. And you can see it's an extremely long list. And here I have a few flowcharts for what to do if something goes wrong, and methods to check the quality. Throughout the folder there are these markings in red pen, and that was comments and suggestions made by the client when he saw my folder. The most difficult part to make out of this whole thing was the top surface, since it required finding a very flat piece of wood and CNC milling all of these circular holes into it. The school's CNC machine actually wasn't big enough to manufacture this whole thing, which is why you can see in my final design I split it up into pieces. But we eventually decided to send it off to a manufacturer who specializes in CNC. So in the final product, they are actually complete, continuous pieces. But that took a lot of time, and in the meantime, what I did was designed a laser cut piece of plastic to act as a placeholder before the wooden pieces could arrive. So you can see throughout the whole folder in these title pictures, those were taken when I had the acrylic placeholder on, which is why they're circular holes instead of spherical dents. I took a bunch of pictures of me manufacturing the whole thing. You can see here the internal structure of the compartments and how I use glue and clamps to hold down the outer skin. And so here's the final assembly process, and here is the product, finally finished, still with a temporary top. But that's not it, because there's still evaluation and testing left over as the last part of the folder. I go through all sorts of different tests to make sure that the final product actually does meet the specification. I also tested out how the spherical pieces would work and played 2 games, one with my friend, my client, and one with my mom. And it's a bit worse on video, but it's quite difficult to distinguish between the colors of the brass pieces and the steel pieces. Certainly not as easy as the black and white pieces normally. So that's a small problem, but I think it's worth it for the very nice feel of the very heavy and dense solid metal spheres. I then officially went through all the specification points and checked if the final product met those points. Here's a page where the clients gave some final feedback, and I talk about how I received the final wooden surface as opposed to the acrylic surface. And lastly, I consider some possible modifications to make the final product and the whole manufacturing process better. As you can imagine, this whole process took a bunch of time. I remember counting, and I think the whole folder had something like 27,000 words and 100-something hand-drawn diagrams. Most of it really wasn't that necessary. It was just coming up with additional ideas that weren't really relevant to the final thing. So I think going through this whole process was a good practice for what it's like to truly dive deep into one project and do everything just the right way, and describing every little thing in extreme detail in this final folder. The joke among students was that DT was by far the most time-consuming class, and it certainly has some truth to it. So I think having this final project and having the experience of going through the whole process was certainly worth it. So thank you for watching this video. Some more's on the screen right now if you'd like to see some more from me, and goodbye.